So without further ado, I'll sort of kick off, and I should say who I am. So I'm Martin Charter. I'm a director of the Centre for Sustainable Design. We set up in 1995 and really involved in a lot of different issues around product sustainability and circularity across a range of different areas. So we're all very familiar with I'm sure, the Elaine MacArthur Foundation model, and that covers the sort of biological and technical systems. There are variations on this. This originally was based on the original schematic from Braungart and McDonough, or McDonough and Braungart. And so sort of the idea, of the biological and technical system. And this has become increasingly sort of well recognized. However, the challenges of implementing this at an organizational and particularly a product level are easier said than done. So what we are seeing is, particularly coming out of the Circular Economy Action Plans 1 and 2, we are seeing more focus around circularity issues and products and broader sustainability from the Commission, and that's sort of broadly breaking down into sort of parts of the life cycle, looking at product design, sale, and use. And a particular note is the emerging policy, related to the eco-design for sustainable products regulations that Martin will talk about a bit later, that is very much broadening the product categories that that policy will be targeted at. And that is also new policy, but also retrofitting existing policy. And I'll touch on that a little bit on one area. What we're also seeing is new policy related to green claims. That will make it make the use of the language and terminology related to green claims much more specific. From that, also, there is policy discussion around digital product passports. So the idea of information-backed claims is becoming more important, and how you collect and track that information across the life cycle. But also, we've had various new regulations emerging from DG Consumer and DG Justice around repair, for example. So we've got different parts of the life cycle being targeted. Oh, can somebody keep their dog quiet, please? Yeah, okay, good. I didn't have to hunt you down. Back on track. So we got policy changes on circularity, and really Europe is really driving a lot of the activities on a sort of global base. If we then start to look at standardization in the area around circularity, particularly, what we had is the first standard around how you tackle the implementation of circularity to organizations was BS 8001 in 2018. And that really was looking primarily from an organizational point of view and provided sort of initial guidance. What then happened in 2018 was the start of an ISO process around circular economy, TC Technical Committee 323. And that process is very close to moving to the end of the first stage, and I'll highlight that in a minute. So essentially, there are a number of standards in development, and what the technical committee does, it sets up a mechanism to to launch new standards. So this is the initial sort of batch of standards that are on the table at the moment, but there may well be other standards that emerge, into the future. So essentially, we will see the launch of the first three global standards on the 22nd of May. So literally next week. Those three standards are primarily target at an organizational level and less so at a product level. The three standards, cover terminology and principles, also on second one on business models and value chains, and the third one on how you measure and assess circularity. So these are the three first sets of standards that there's been sort of global engagement with. One of the key things, and be having a role as heading up the Circular Economy Committee at BSI, I've been quite engaged in these and had some sort of observations on this, and I'll keep those extremely limited, but it's been a problematic process because you've still got parts of the world that think circular economy is recycling, trying to get 180 countries within ISO to agree, key principles and elements about what this means at an organization has been a challenging process. In addition, running a complex standardization process during COVID, very problematic when people couldn't meet face to face. So I'd say, as been summed up by one of the experts in the group, that we are perhaps with these first three standards where we were at the beginning on ISO 14001 and ISO 9000. They're absolutely not perfect, but they're start of maybe a 10 to 20-year process on standardization. And again, I won't dwell on it, but I'll leave you to work it out. But immediately, the date on which the standards are launched, immediately they will go into revision. So they're absolutely not the done deal yet. So there are other standards in development. And from a product point of view, the most notable one is on product circularity data sheets. So this is looking at circularity and sort of information. In parallel to this, we now have a European standardization process starting, TC 473, Technical Committee 473, and this process started in the fourth quarter last year. Within that process, there is a series of ad hoc groups that have been set up to look at 4 different categories. What then will happen is from these ad hoc groups, new work items for standardization will be proposed. And then, in quarter 3 or 4, the likelihood is standardization will happen in these areas if there is a consensus agreed within the European, within the countries involved in SEN. Within that is the member states, but also UK and other European countries are involved in the process. So those first 4 standards are again on terminology and framework and principles, and it's likely that there will be a building on what ISO have started with. There was initial discussion, and that will be led by Germany, by DIN, the German standards body. Initial proposal from Germany for a digital standard on digital passport, but the general agreement was that it is too early until the Commission defines what it means by digital passports. It's too early to say, particularly because there's over 100 public funded projects on digital passports out there. So what was agreed is to start to look at the whole idea of information sharing through the value chain. There is also a proposal for an extended producer responsibility standard, haven't got time to go into this today. I think this is, slightly challenging area because extended producer responsibility is a regulatory term. It's embedded in the European waste regulations. So the proposals in terms of standardization specifically for organizations, we're due to see what comes out of those discussions. France is also leading a standard on circular business models, which will build on what has been done in ISO. A plenary meeting in Berlin in June, where the proposals will be discussed. In addition, there's been standardization activity happening around materials efficiency, particularly initially related to the energy-related products sector, under the TC10 committee. And this has really covered, in effect, a lot of product circularity areas, from repair to remanufacturing to recycling. So this is, it's under a heading of materials efficiency, but you could argue a lot of these are product circularity strategies. And what there are behind these is a series of working groups. There's been standards already published in those areas, but there is ongoing activity in these. My understanding is that with the developments related to the eco products, eco design for sustainable products regulations, there is now a brief to again broaden the standards to be usable and readable by, if not all products, all sectors, a broader range of product categories. So this is a sort of broadening out of the focus from energy-related products. We've also got other standardization happening in circular design, from fishing nets to the Working Group 8. And Working Group 8, which I'll come to in a minute, it's again a standard getting fairly close to publication on circular design. So we are starting to see circular product design almost becoming, starting to be better defined, but the areas such as regenerative design, the terms regenerative, for example, are also starting to move into the discussions and starting to move into definitions, but are less well defined. So, for example, we have this definition that highlights, a definition for circular design of products, but in the note there, it talks about, products, retaining products and materials to the highest value, throughout, life cycles and within economic and social systems, but it also introduces the idea of, regenerating nature. And so that area is starting, we're seeing words like that move into standardization, but they're not really very well defined at the moment. The Working Group 8 standardization within SEN is, I won't go through all these slides for time, but it's really looking at how circularity can be, integrated into design and development, considering life cycle, and sort of managing trade-offs, and I'll come back to that in a minute. There are quite a number of quite useful, tables and stuff to help companies think through these issues. But again, actually, I think I missed out a slide there. I mean, one of the key elements from this Working Group 8 is that initially the focus was, like the other areas I mentioned, on energy-related products, but now explicitly the group is revising that standard to cover all products, all sectors. So this is again part of a sort of broadening of the activities from the Commission on policy that's then feeding through into standardization. If we go back to the point here about trade-offs, one of the key things there is that essentially, if you're designing for circularity, but you're not thinking about energy use, water use, other parts of the life cycle, this might be you consider to be sort of problematic. So again, I think one needs to look at the context of circularity in the broader scheme of things, dependent on dependent on the product and its key environmental impacts. These standards are very much looked at guidance, particularly. What we have is, going back into the 90s, we have the whole emergence of design for environment, eco-design, environmentally conscious design, and we have already standards in place at a product level and a management level around eco-design. Eco-design is much broader than for example, circular design. So how the new standard on circular design aligns with the existing broader standards is something that needs to be considered. Again, I'm not just going to read through this, but essentially within standardization, you have well defined within both ISO and IEC. You have a standard definition of eco-design, and that's much broader than circular. So just a couple of quick points before I pass across to Patrick. We've just been part of a Horizon 2020 project looking at product circularity within the context of a life cycle sustainability assessment methodology. We've been particularly looking at the product circularity aspects. And I think many of you from industry won't be surprised to see, some of at least the perceived barriers to the incorporation of product circularity at a product level are actual or perceived cost, the need to maintain functionality and product performance, and particularly these issues of aesthetics, what the market will is looking for. Again, quite a lot of information here, but essentially, in essence, I'll just extract a couple of key points from this. We did 20 to 21 depth interviews with companies, startups and large companies already on the circularity journey. What we found was that the vast majority of companies were not at a stage of having mature approaches to measure circularity at a product level. What we also found was that perhaps life cycle analysis tools were really there needs to be more work done in this area, because a lot of the tools weren't really looking at circularity, particularly in a broader life cycle context. And essentially, the bottom line of what we found was that where activity was happening on a product level, the vast majority was at the level of materials. And for example, how can we incorporate recycled materials or bio-based materials? Despite, academic discussion, high-level think tank discussion, there was much less activity in terms of integrated take-back models, that were, bringing products back, repairing, reselling, remanufacturing. So that broader life cycle, product circularity business models was much less evolved. So I'll now pass across to Patrick.
Okay, that's great. Thanks, Martin. Yes, so as as you know, when circular economy is mentioned, it's always says it's also regenerative by design. And as Martin showed in some previous slides, this term of regeneration is now also emerging in some of the standards that have been being developed. However, regeneration as such is not well defined as such, and even less so regenerative design. And this is something I've been trying to understand a bit more about. So go to the next slide. Now, all this is still a work in progress. And probably, I need to say, I'm here. We have a fire alarm going off in 5 minutes, so there'll be a small disruption. I'll just put myself on mute, so you're not surprised when that happens. But to start off with, so we seeing a lot more of the last couple of years. In particular, I think I've observed a lot more claims of regenerative companies, regenerative businesses, regenerative business models. These are some examples here. So as you could say, there's proliferation of these claims, but the question is really how to measure these. What is actually behind these claims, and that's not again that will require obviously standards and metrics to be able to do that. So the next slide, please. So what I've tried to do is to, and this is again based on the Alan MacArthur diagram. On the left hand, the biological systems, on the right hand side, the technological systems, to distinguish different design principles and practices for each of these. And so a lot of the standards that Martin introduced earlier, a lot of this is in this space. I would say these principles here on circular design, whereas regenerative design has a number of other principles. So living systems approaches, self-healing properties, self-assembly or even self-disassembly, renewable and bio-based materials, bio-inspired design, biomimicry, and then also the ambition to have a net positive impact on natural systems, not just doing less bad, but contributing to rebuilding ecosystems and natural capital. And yeah, so what I've tried to do is to dig a little bit more into these regenerative design principles. And what I have is a few background slides more on theoretical background on regenerative design, and which is then followed by a number of product examples where we can see these principles being applied in practice. Next slide, please. So so regenerative design, although there's the proliferation recently, is not a new terminology or a new idea. It's been around at least since the 1990s. So I have a quote here. Also, there's John Lyle, who came up with regenerative design for sustainable development, who also created the figure that you see here on the right. And so this has been already quite well-established approach in landscape architecture, for instance, and we can see Royal Institute of British Architects has already a definition there, which I put in here. It's also, as we know, from regenerative agriculture. It's also there, well-established, but not in other, let's say, sectors or product categories. And then if we click to the next slide, or at least, so yeah, again, sorry, if you go back one. So this is the question here. Again, creating this positive impact, regenerating nature is really question. How do we measure this? And so this is one of the big questions. So now, next slide. Thank you. So it's also in the literature, there's been this this attempt to distinguish between restorative and regenerative practices in the circular economy, and the aspect of restoration is better defined already. So there's restoration ecology, etc. But again, regeneration is still, in many cases, a rather symbolic or evocative term, also with limited practical application. Although that's also beginning to change, as I want to show also a bit later. Next slide, please. So then again, going back to the very foundations, really to understand. Apologies for that. It was only a short test. So yes, going back to understand how biological systems regenerate. So all living organisms have this ability to regenerate parts of bodies. Stem cells play an important role here. And so again, and I put in this example of the zebrafish here, how it can regenerate its fins, etc. So, and these are some of the mechanisms within natural systems that we might want to look at in more detail to then understand how that applies to potentially also artifacts and let's say technological products. Okay, next slide, please. So again, there's also a link to concepts of autopoiesis, which was developed by Chilean biologists already back in the 1970s. So, and here some of the findings is that actually self-regenerability is decentralized. So it's not just located in one place of the organism, and the interconnected relationships of the different parts of the cell and the organism are also key to these things. Okay, moving on to the next slide. So now when it comes to moving from those principles towards now standardization, we can see that this is also already beginning in regenerative agriculture and agroforestry. So this is, I won't go into the details here, but here the question of how do you measure this has already been, I would say, addressed to a large degree by practitioners and researchers. So there's already specific criteria, but also criteria thresholds of when, for example, an agricultural system or an agroforestry system can be considered to be regenerative, and it's quite detailed. And in this case, you'll be able to quantify the aspects, looking at also, yeah. Okay, and next slide, please. So now I've tried to look at some products or product innovations that are emerging, which could seem to be combining some regenerative and circular design principles. And so this is new engineered wood product, cross-laminated timber. So if it's basically wood that's being used from regenerative forestry practices, then used, as you can see, how these then are these modules, and modularity is one of the characteristics of circular design. Then we have a very good combination of how these can come together. And this is not only theoretical, but there are many multi-story buildings, especially in Scandinavia, but also many other parts of the world are using this approach. Next slide, please. Then one of the other aspects of regeneration is the aspect of self-healing properties. And there's quite a lot of interesting research happening on self-healing materials, which basically can, the materials including polymers, metals, alloys, composites, but also concrete, ceramics, and they can heal themselves to a certain degree. So which is, again, say, nature inspired. And just over the last few days, I've been looking a little bit more at how this is already applied. And actually in the context of electronics and specifically mobile phones, there's now new things that are probably going to come into the market in a few years, would be self-healing screens on mobile phones. So I found Apple, for example, already has a patent on self-healing screens. I saw one article which says that by 2028, these will become kind of mainstream features of new mobile phones. So that would be really interesting development to see, because a lot of the repairs that are needed on phones obviously is cracked screens. So if that is already addressed, that would be a very interesting new stage in product design and product innovation. Next one, please. So I've also looked at solar PV panels, and this is an innovation from ITRI, an institute in Taiwan, Industrial Technology Research Institute, who has developed and is in the process of also commercializing this, a modular circular design panel where all the different components, all the different layers can be easily disassembled and reused. So this would dramatically change the picture that we have at the moment, where solar PV is predicted to generate a significant waste problem, not in the very near future, when the first generation of panels coming to an end of life. So those panels haven't been designed in a way that they can be easily assembled, but need to be crushed, and many of the materials are difficult to recover. Next stage, sorry, next slide, please. I've also tried to find examples of where regenerative design principles are being applied to solar technologies. This is an interesting innovation coming out of Imperial College. So a biomimicry photovoltaic leaf that not only looks at the shape of leaves, how to use it, but also tries to copy the processes within leaves on how sunlight is transformed into energy. There's also other new design kind of different types of shapes within organic solar. It's the Solidus Arc is a startup company based in London. So it uses organic thin film solar, is recyclable, and apparently doesn't contain any rare earth metals. So that's also an interesting potential for more regenerative solar product going forward. Next slide. So then there's also what you could call regenerative biophotovoltaics. So these are microbial fuel cells. They've also been called living solar cells, and they work with self-assembly and self-repair principles. Won't go into detail, but these are not commercialized, but mainly in the lab, although that research has been going on for quite a while. But the energy outputs from these biophotovoltaics is still comparatively low to actually what we currently have from other PV systems. Next slide. Then I've been looking at some laptops as examples. So obviously modular design is coming up. There's the concept Luna by Dell, framework laptop. So these are work on similar principles. There's also Fairphone, for example, where users can easily on their own swap components or upgrade their systems. In terms of regenerative design, there are some new solutions emerging, bio-based PCBs, for example, different types of like flax fibers that can replace plastic, etc. But that's, I think, still only emerging. We can't see that on a wider scale yet. The next slide, please. So then, and this is something where I need to look at in some more, but when we have natural systems, obviously one of the characteristics of products in the natural environment is that they automatically biodegrade. Well, automatically, for us, automatically, obviously, there's different organisms involved in the biodegradation process. But it would be interesting for future product design, especially in terms of electronics, to think more through what can be learned from these biodegradation principles. And this connects to, I think, not only research, but also practical examples already where we have automated disassembly of electronics. And one of the examples, obviously, is Apple's Daisy robot. And I've put in this table here, levels of automation for disassembly tasks. And so I think the Daisy robot, having had the opportunity to visit it recently, ranges quite high on this. I think probably scale 6 or even 7. There are still people involved in overseeing the process, but also then at the end sorting parts of the components which then have been disassembled. But I think that's also has a lot of potential, not only to become adopted more widely, but also next levels of automated disassembly, maybe also automated upgrading of phones and other electronics. Next slide, please. And then I think this is my last example. There's also researchers in Italy have designed this Philobot, and I think this is also funded by a Horizon 2020 program, self-growing robots, which use also natural or principles of how plants react to light and shade, and depending on that, change their growth path. So these principles have been built into the design of this robot. So really interesting innovations there. Next slide. Right. In terms of electronics, there are new developments also still in the lab to look at fungal electronics using mycelium-bound composites, not only to make devices, but also to use it for computing. So, which is a very different approach to how we do computing currently. So I think it's also really interesting to understand more on these things, especially because mycelium was very popular in other types of circular product design when it comes to packaging. So yeah, interesting area for more research as well. Next slide. So this is my last slide. So some of the questions now is, we kind of see a gap between what's the current state of practice in electronics design, for example, what's in the market or what's coming up, but the state of the art in terms of new design innovations. And the question is, how do we close that gap, and specifically look at also how design standards, including maybe EU regulations, relate to this. So what standards and guidelines could be developed to ensure adherence to regenerative design? How would these be integrated into existing industry practice and regulations? And then big question again also, how this collaboration and knowledge exchange between industry, government, standardization bodies, civil society, research community will work, and how can this be fostered to advance regenerative design in electronics. Yes, that's all from my side. I stop here and hand back over to Martin. So happy to take any questions if you want to put them in the chat. I can answer them. There's also time at the end for Q&A.
Okay, well, thank you, Patrick. Excellent. And so as Patrick said, I mean, please feel free to post questions, and I think Patrick's happy to answer them the best he can, or we can pick them up in the round in the final 15 minutes. So I'll now stop sharing this screen and then pass across to Jonas, hopefully. And it looks like, yeah, so
Hi everyone, did that work? Martin.
Yep, we can hear you fine, and we can see hello.
That's good. Hello, my name is Jonas. I'm part of the environmental initiatives team at Apple. I'm really happy to have the chance to be talking with you today to give you an overview of what we do at Apple when it comes to the environment at large, but in particular when it comes to the question of circular design and how that fits into the broader picture of Apple's environmental initiatives. With that, let me get started by acknowledging that we are in a dire situation when it comes to the environmental crisis that we're dealing with. And so we at Apple have been on a journey for a few decades now of addressing that proactively and very strongly. The current strategy that we are working with and towards is what we call Apple 2030. By 2030, Apple has committed to be carbon neutral. And obviously that needs explanation, that needs a deep diving and further explanation. And so I'm going to be doing that in the next few minutes. And I'm starting at this point in our environmental journey because the question of circularity and circular design really features into and feeds into the strategy. Without the circularity aspects of our environmental strategy, we would not be able to achieve our Apple 2030 goals. So when I say Apple will be carbon neutral by 2030, what I mean by that is that our strategy includes the entire product life cycle. So not just our corporate emissions, but also the emissions of our suppliers, the emissions that are associated with the use of our products and with the transport and with the recycling of our products. We, in 2015, were responsible for about 38.4 million metric tons of CO2 emissions. And our goal to, by 2030, be carbon neutral entails effectively a two-pillar strategy. On the one hand, we're going to reduce our emissions by 75%. And for the remaining 25%, which are emissions that we believe that within the time frame of 2030 are not addressable technologically, we will do high-quality nature-based carbon removal solutions. So how that translates into our carbon footprint is what you see on this slide here. On the left-hand side, you see what we call Scope 3. These are emissions that we are not directly responsible for, but they are associated mostly with our suppliers. And on the right-hand side, Scope 1 and 2, these are emissions that we directly control. As of 2020, we've been carbon neutral as a company when it comes to the right-hand side of this equation. And on the left-hand side, what you see is that obviously a huge, huge chunk of our emissions are related to product manufacturing, 59%. And within that, obviously, the question of circular design starts to appear. So the way we are addressing our footprint is effectively through 4 different avenues: designing and materials, electricity, direct emissions, and then carbon removal. I've mentioned that as a company, our retail stores, our offices, our data centers, our employee commute, all of those things are already carbon neutral and already for 4 years. What we're working on now is to transition our entire supply chain to 100% renewable energy. That requires working with our global suppliers around the world to help them transition to renewable energy for their production. It includes helping them to connect to high-quality renewable solutions, helping them to make their operations more efficient. And so at this point in time, more than 320 suppliers have already committed to 100% renewable energy. That represents about 95% of Apple's direct manufacturing spend. We're really at a very, very good, on a very, very good path. And when I say committed to 100% renewable energy, what I mean by that is that they are either already using 100% renewable energy or they will do so by 2030. In total, they've committed to about 21 gigawatt of clean energy to bring that online in that period. 16 gigawatt of that are already online. That translates into more than 18 million metric tons of carbon emissions avoided in our supply chain. And just for Europe, for instance, we've just recently announced earlier this year that together with the Spanish International Solar Development Platform, IB Vogt, we will partner to run and bring investment in solar power just in Europe for 105 megawatts of energy online. So with that kind of framing, I'm now going to pivot over to the question of circularity in our supply chain and in our products. How we define our circular supply chain is the following. We start with the sourcing of materials. The best material is the one that you've never had to source. But obviously, we are sourcing material, and there's plenty of material that we're sourcing. So then the question becomes, is this virgin or is this recycled content? And we as a company have set ourselves a target to one day be able to use only recycled or renewable material in all of our products. The moment you have sourced your material, you want to look at how efficiently am I deploying it? And that is a question of design. And then the moment you have committed your material, the environmental damage is done to a large extent. So then the question becomes, how can I ensure that the product, and with it all of the embedded materials, lasts as long as possible, creates as long as possible value for the consumer so that they don't have to go out and buy a new one. At some point, obviously, there's going to be an end of life to every product, and then the recovery phase becomes very important. Are we able to get those products back? Are we able to recycle them? Are we able to recycle them to such an extent that we can bring them back into our sourcing strategy? And so all of what we are doing here is really impacting how we are designing with circularity in mind. And obviously, the idea here is a real focus on quality and durability of the products in order to make sure that they last a very long time. So when I then kind of unwrap that a bit, then let's focus on what we call our priority materials. We at Apple have defined 15 materials to be our priority materials on the basis of environmental, social, and supply chain investigations. We have material impact profiles for all of our materials. We've done that for over 40 of them. In order to understand what should be our priority as we close the loop, as we go about tackling material by material to make sure that we're using recycled or renewable content only in our products. And so what you see on this slide here are the 15 materials that we've defined on the basis of environmental, social, and supply chain considerations to be our priority materials. Steel and tungsten, lithium, plastics, titanium, paper, zinc, copper, cobalt, rare earth, tantalum, tin, glass, aluminum, and gold. These materials account for more than 87% of the total product mass that we ship to our customers. So if only we're able to close the loop on these 15 priority materials, we're almost 90% on the way to having closed the loop entirely. And so to give you an idea of where we stand right now on that journey, we've started in 2015. We've added a recycled plastic. Then in 2019, tin and rare earth and aluminum in some of our products. We've continued doing that. We've added cobalt and gold and tungsten in 2021. And now 23, copper and titanium and zinc. And so what you see is that we're working through materials, material by material rather than product by product. The totality of the work that I've just shown to you represents at this point in time 22% of the material that we ship in our products, which come from recycled sources. Some of the material has already reached a significantly higher recycled content rate. So tungsten, for instance, we're at 99%. Aluminium, we're at over 70%. Rare earth, we had over 70% of total mass in all of our products. For lithium and cobalt, both of those materials are very important in our batteries. We are at over 20%. And so all of that adds up to a totality of 22% of recycled content across our products. Now, in April 23, we accelerated some of our work through new commitments to transition to 100% recycled cobalt, tin, gold, and rare earth elements and select components by 2025. So watch the space. It's a pretty ambitious timeline. Now, if you remember the circle that I've drawn, we've talked about efficiency, we've talked about sourcing. I'm now going to talk a bit about longevity. So when we look at products that last, then we think we can do three things to improve the longevity of our products. The first thing, and arguably the most important one, is durable design. No customer likes it when they have to bring in a product for repair. They'd much rather it didn't fail in the first place. Software support, we're making sure with industry-leading software support that both on the functionality, on the security side, our products are supported for a very, very long time. And then in the unpopular and unlikely event that a product might fail, you need to have a repairable design and you need to have a repair service available to make that possible. So I'll talk about those in a bit more detail. When it comes to our reliability testing, we know that keeping a product in use as long as possible is central to conserving resources and lowering product emissions. And the durability of our hardware is the first critical factor for such a long-lasting device. Now, we know that we're producing very portable devices that are being carried with our customers to a lot of different places, and that are being subjected to grueling conditions. I, for instance, have children, and those children will drop devices by accident, but we are testing for those kind of conditions. I want to give an example with the iPhone 15, how the testing that we do is translating into design features. And so on the left-hand side, you see features that enhance the durability. On the right-hand side, you see features of how our product is repairable. The first thing I want to highlight is the liquid ingress protection rating that our phones have. In other words, they are protected against ingress of water or other liquids into the device that would then have a potentially catastrophic impact on the electronics. By protecting them to such a high level, IP68, we are reducing our failure rates, and we're making sure that products don't need a repair. The sapphire crystal lens cover, the aerospace-grade aluminum enclosure, the ceramic shield display, all of those things help in the case of a drop, for instance, to ensure that our products need less repair. Now, in the event that they do need a repair, we are making sure that there's the possibility to do a repair by design. And so I want to highlight just a few of those components here. One of them is the back glass. we have changed the internal design of our iPhones in order to be able to support the replacement of the back of the phone. By doing that, we're reducing repair costs, but we're also reducing the emissions, carbon emissions that are associated with the repair in the first place. And so this is just one example of many of how we are seeing real good improvements on our repairability journey over time. Now, having said that, when you have a device that can be repaired, the next question is, do you have ways of repairing it? And so I wanted to highlight that we have started to increase our repair channels in such a way that I believe they are industry leading at this point in time. People will know that we have in our retail stores geniuses, so-called geniuses that are repair professionals that can help with the repair. But we also have a repair channel, which we call Apple Authorized Service Providers, over 5,000 locations worldwide. And a few years back, we've also added a new possibility for independent repair operators to associate themselves with Apple to obtain repair capability. And so over 4,500 of those locations are now online. And they have access to the parts and the tools that Apple Authorized Service Providers and the geniuses in our own retail stores have. They have access to the genuine parts that are being used, and training. And as a matter of fact, about 1.5, 2 years ago, we've introduced the same sort of access for individuals through what we call self-service repair. In total, the professional side of our repair covers about 100,000 Apple certified repair technicians. At some point, if you remember the circle that I've drawn, at some point there's going to be an end of life to your product. And so what we want to make sure is that there's the ability to trade in a device for credit or to recycle it for free. When you bring your device to an Apple retail store, for instance, or online as well, you're going to be asked, do you have an old device that you could give back? In case there is value attached to that, in case there's a possibility to give it a second life, we will make sure that that's happening, and we will offer a discount, a credit for that device. But if there's no value attached to the device, we will also take it back and we will recycle it for free. And with that, I wanted to introduce and kind of come back to something that Patrick already shared, and which is the innovations that we're driving in the recycling space. We have three robots, but the first robot that I want to talk about is Daisy. Daisy is the automatic disassembly line that Patrick has mentioned and has already seen, which is able to take apart 29 different components of from an iPhone. Sorry, 29 different models of iPhones into 9 distinct select components. And that activity allows us to recover valuable key materials from the devices. It helps us recover materials from select components, sending those select components to specialty recyclers. Dave is another example of robots just like Taz, which help us recover valuable rare earth magnets like tungsten. It's a really important innovation because they are very effective. From just 1 metric ton of iPhone components taken apart by our recycling robots, recyclers can recover the amount of gold and copper that companies would typically recover from 2,000 metric tons of mined rock, in other words, of virgin exploitative processes. Daisy, Dave, and Taz are just part of our recycling innovation journey. We're exploring even more recycling solutions, recovery solutions at our material recovery labs. And so all of that comes together in what I hope to be a very coherent and comprehensive strategy for circularity. It shows up in our products. So what you see here on the screen is our MacBook, the MacBook Air that we've launched earlier this year. It's the first one that has crossed the threshold of 50% recycled content in total product mass in our product lineup. And I've started this conversation by saying that our circularity work is contributing significantly to our carbon emission reduction strategy. And you see that in the example of the MacBook Air, for instance. So the carbon footprint that was associated with the MacBook Air in 2015 was at 283 kilograms per product. By the work that we are doing, and I've just explained a lot of that, whether that's the supplier efficiency work, a renewable energy, whether that's the recycled content work, aluminium, for instance, the recycled aluminium has a significantly lower carbon footprint than virgin. We're able to reduce the emissions, and we've reduced them compared to 2015 for this model by 125 kilograms. And so that translates into a total carbon footprint of this product to only 158 kilograms. That's not yet where we want it to be. We want it to be even lower, but it shows that a very clear path exists to reduce carbon emissions, and we are going to drive on that path even more. So to summarize, the progress that we've done towards net zero emissions baseline, you know, was high. We've reduced by now by 55% compared to 2015. And that is in the same period as we as a company have grown. We've actually grown by 64% by revenue in that same period of time. So with that, I'll close. You can find more information on apple.com/2030. We also have a new environmental progress report that was launched just earlier in April 2024. And if you're interested in environmental footprints and impacts of specific products, we have that available with our product environmental report for every one of our products. Thank you very much.
So thank you very much, Jonas. And have you stopped share? You've stopped screen share? Have you? Yeah. Yes, I think so. Yeah. So, yeah, if you've got any, I think again, Jonas is on the call until to the end of the workshop. So I'm sure if you have any sort of specific questions, he'd be happy to sort of help if he can. So hopefully we've done the technical conversion, and can you see your slides, Martin? Phew.
Yes, I can. Thanks a lot. Thanks a lot, Martin.
Okay.
So I'll take it from here then. I will try to give a glimpse of what we're working on in the European Commission in terms of eco-design. As I said, myself and our Director General for Research and Innovation, we're obviously working on the research and innovation side of things, as I said, but there's obviously also a policy context to the whole story, which is not part of my work, but I can at least give you the overview of where we are and where the regulatory developments are going to. So let's move on to the next slide, where there are a few aspects of why there is actually need for action in this regard. And so we will zoom out a little bit from what we have heard so far from the very practical level from Jonas and before that on the standardization part as well. And as you can see, I'm not gonna read out everything, but you will see the many pressures that we are facing with. And maybe I would just point out on top of the impacts that you can see before you, the environmental impact, obviously. There is a new report that came out a couple of weeks ago. I think it was basically just before the World Circular Economy Forum took place in Brussels, where the new report of the Global Resources Outlook 2024 was published, and they actually have updated some of those figures or precise them even into what kind of impact we're looking at. And one of the latest one I put there is the last one, where we are actually seeing that about 55% of the total greenhouse gas emissions come from resource extraction and processing. So this has been further refined, this number, and reaffirmed as well. So we see that the impact is really, really big, coming from the resources extraction. and processing, and therefore even more we are going to be looking into circularity aspects and all different aspects of circularity, not only recycling, of course, but even more we're going to be looking at higher up the value chains in terms of eco-design, design for circularity, starting from chemicals, from raw materials, going all the way down to through the value chains, looking into repair, reuse, looking into refurbishment, remanufacture, and other strategies of circularity. So this is going to be the focus of the next, I would say, years, especially, and definitely in the research and innovation area. So let's move to the next slide. And let's just kind of reflect on what has happened, and we're all very much aware of that. And we had the COVID crisis, we had the global disruption of the value chains, and when we all thought this is finally over, then the war in Ukraine came, and the global instability in terms of supply chains and resources has continued, and all the impacts that you see on the slide, and probably there are many more, but these are the main ones, are having a big effect on our lives and on the economy and on the businesses, and on the citizens as well. So we need to look into all of these aspects, such as not only new business opportunities, but also looking into local jobs, social cohesion, resilient supply chain, less pollution, of course, and not forgetting the industry, of course, because that should be also more taken on board. Let's move on to the next. So looking into the regulatory context or the policy context, what we're talking about is implementation of the Circular Economy Action Plan. And here you have a list of, not all of them, but few of the regulatory measures that have been put in place and that are being still now in the process of being agreed. And some of those that you know very well: the packaging and packaging waste regulation, or a strategy on textiles, policy framework for bio-based, biodegradable and compostable plastics, which might lead to specific legislative measure later on, microplastics pollution, update of the monitoring framework for circularity at the member states level. There are many more others that I'm not going to list here, but there are also other important ones which are relevant for the eco-design topic, and that is those measures have not been agreed and adopted yet, but they are at a very, let's say, advanced stage of adoption. The first one is the eco-design itself, the eco-design regulation. That has been now at the final stage because the co-legislators have agreed on the text. Then there is a right to repair directive, very important one for one of the circularity strategies of the eco-design. Another one interesting is on empowering consumers for the green transition. So those will be also having a necessary and significant impact on the market. Let's move to the next. So to remind you, the Circular Economy Action Plan has in its scope 35 actions, and looking into, obviously, sustainable policy, sustainable product policy framework, looking into the key value chains that have been prioritized, such as the electronics and ICT, packaging, plastics, textiles, construction and buildings, etc., etc. Within these value chains, the focus was to not only, but primarily to reduce waste exports, and boost markets for secondary raw materials. But also now, as I said, we want to focus also on more higher up the chain circularity strategies to make products more durable, repairable, reusable, and to slow down the material consumption rate, basically, so that we can keep as much material as possible within the economy and reuse it again, and to reinforce the strategic autonomy of the EU given the geopolitical context currently. And there are other aspects that are important on the right side. You can see the slide. So obviously, this is a difficult transition, and we are very much aware of that, because we call it the green and digital transition. But it also needs to work for people, of course. So it needs to be feasible, and it needs to also work for people. So we need to get everybody on board, and to also get the financial markets and the consumer citizens, and we need the necessary investments to get into these sectors, which is not always an easy task. And last but not least, we have to ensure proper monitoring so that we can measure how far we are and where are we going, and what needs to be done. Next slide. So to give you a little bit of a flavor of where the eco-design regulation is at, here you have a couple of dates, which are not so important, but basically quite recently the co-legislators reached a provisional agreement on the text that needs to be approved still by the European Parliament and the Council. In December, at the end of last year, there was an approval by the permanent representatives of the member states, meaning the Council, at the experts level. And in January this year, the European Parliament's Environmental Committee also approved the text. So now what is coming next is the adoption by the European Parliament in the plenary, which is official approval, let's say, the official voting in Strasbourg. And then it should be approved by the Council at the higher level, basically at the level of the governments of the member states. And what comes after, there will be the implementation phase, which is actually the real work. There will be a work plan to be published after the entry into force of the regulation. So next slide. How will it look like? So how will the ESPR work? So there will be the framework regulation, the actual ESPR, eco-design regulation, which will set the general requirements. And in the next step, there will be specific product requirements set in the second stage through detailed measures, so-called delegated acts. And there will be, on a product-by-product basis or product group basis, there will be set specific requirements for those products. And this will be done on the basis of an annual or multi-annual working plan, and this working plan will be updated regularly based on which products and product groups will be prioritized for the eco-design. Next slide. So yeah, as Martin mentioned, I believe at the beginning, the eco-design is not a new thing. It comes from the energy-related products. So this is the current eco-design proposal. The regulation proposal is extending the current scope of the eco-design beyond the energy-related products. That's the main message. There will be some new requirements for specific products, and there will be especially horizontal requirements which apply to multiple products across, such as recycled content, for example, or durability, or reliability, and things like this. But also there will be the new provision for digital product passport, which is a new element in terms of transfer of information about the product. Next slide. Yeah, there will be other tools as well within the ESPR, such as mandatory green public procurement. This will help the public contracting authorities to set specific criteria for products to comply with eco-design. And there will be also an important part on market surveillance and customs controls, which is a very, very important part of the whole story, and the digital product passports should play a very important role in that as well. So that will be there as well. Next slide. Yeah, I think this is just going to specific details. I'm not going to go too much into technicalities, just to show you, not important what the articles numbers are, but the eco design basically is setting the provisions of two different requirements. One is performance requirements, and another one is information requirements. So performance requirements is basically what characteristics will need to be tested, and which eco design requirements are going to be there, and which characteristics the product will need to have and to comply with. Whereas the information requirements will be specifically about the digital product passport, meaning how and which information are transferred through the digital product passport so that they are visible to the next one in the value chain, or for example to the enforcement authorities such as the member states and customs, etc. Next slide. Yeah, we can move over to this. Well, actually not, because this is mentioning standardization, which is important here in this context here. In the digital product passport as such, there are three levels of provisions. So there is basically the regulation that establishes the digital product passport concept and describes the scope, of course, but then there's also a standardization process, which will be about developing the essential technical requirements. And this is also an ongoing work that is going on through different projects, but also through standardization. And the delegated acts will be the third one, setting the specific requirements for specific products and product groups, as I mentioned, but we already mentioned that before. So we can go ahead to the next one. Here, yeah, I just put the overview for you. Those of you who haven't read, this is from the JRC technical report about eco-design, the ESPR. So I would very much recommend to every one of you to have a look at this, because it's a very interesting piece of technical work into specifying the requirements or possible horizontal and sometimes product-specific requirements that could be taken into account into the eco-design. And also the JRC reports, or our colleagues from JRC, they have made scoring, an indicative scoring of products and product categories based on their environmental pressures, as you can see in the different columns, and including the strategic autonomy relevance in terms of political and geopolitical situation. And so this slide and the next slide are listing the products that are being looked at, also at the Commission for the prioritization, as I said. These products that you're looking at right now, those are a final product or end products. And the next slide is listing the so-called intermediates, which basically are the step before making the final products, and they have their specific categories. So they're dividing them into two. Intermediates and final products. There you can see the indicative, importance and environmental pressures of each of them. So let's move to the next one. Okay, so this was about eco-design as a let's say policy and regulatory context of the story, and I just want to give you a flavor quickly now about what we are working in DG R&I in terms of programming. So let's move to the next slides. Yeah, well, we have been drafting topics for the work program 2025 in these days, and we are following a certain logic that we have identified several years ago for the Horizon Europe and for the strategic plan that we're following, identifying the problems that we have, and many of them you have already heard many times and are aware of, and the challenges that are that we have within the individual value chains of the Circular Economy Action Plan. And in many of the sectors, the challenges are identical or very similar. But you can see that except or besides the problem with recyclability and let's say use of recycled material or even recycling of current products, we have also challenges identified in terms of lack of design for sustainability and circularity, no user involvement in product design, limited ambition and scope of eco-design, procurement, unsustainable product lifetimes, lack of repair services, etc., etc. So there's many things that you can see, and that the eco-design and research related to that aims to address. So next slide. Here you see that. So what we are dealing with in terms of circularity in Horizon Europe, this is all under so-called cluster 6, which is kind of an envelope within the Horizon Europe, and specifically Destination 3. And Destination 3 is circular economy and bioeconomy sectors. And we have been programming and writing calls and topics, specific topics, which you can see on the slide. And firstly, we are writing topics in, let's say, the context of territorial deployment of circular economy. So this is very much focused on cities, municipalities, and regions. And there's a specific initiative called CCRI, Circular Cities and Regions Initiative, where there's a specific amount of R&I budgets going into research and testing and demonstration and implementation of territorially specific solutions on waste, on construction waste, textiles, plastics, etc. But secondly, there's also a sectoral approach that we have been taking, or we've taken, and you see that the areas where we have programmed topics for research calls, such as plastics packaging, building and construction sector, textiles, plastics, electronics value chains. And last year in the work program 24, for this year's topics, this year's calls, we had specifically 2 dedicated topics on textiles, one on textile EPRs and one on textiles value chains, one on plastics and one on electronics. And we also had a topic on household, on circular households, to be able to kind of look into an innovation action, to be able to compare circularity of households among each other or between themselves. But also we looked into tourism, because circularity in tourism is a very big issue as well, as you can see, as you might have noticed, and also furniture, which we see as one of the emerging topics or sectors or ecosystems, or how to call it, where circularity needs to be taken into account as well. So next slide. And besides the regular calls for research and innovation actions or innovation actions, we also have other actions on the Horizon Europe, which are mainly procurements or other indirect actions. So we have now running 3 studies actually. One is on circular economy indicators and methods. So there's a study that is going to define or propose circular economy indicators and metrics, how to measure the status and progress to circularity in specific areas, specific value chains, and in specific levels of granularity. So national, local, and very granular level. And this study is coming to an end slowly. So in September we should have some interesting results to show. And the second study we have is going on inter and intra value chain collaboration. This is also about circularity. So we're doing a study to see what are the dynamics and interactions among and within industries and value chains, and how does that impact circularity transformation in those sectors. And there is a third study on life cycle information, which is a bit more specific to for example, PEF, the product environmental footprint assessment. And then just to lastly mention, we have also activities which you should know about, where we are looking into how to help the deployment of major solutions, new technologies, or new innovations, and how to basically bring them closer to the market and help the replication of those solutions. So there is a facility together with the European Investment Bank called Circular City Center, C3, which is providing some support for circularity related projects, and another one called Circular Economy Technical Assistance Facility as well. Besides that, there's an OECD program for cities and regions, and that is also helping the deployment. And lastly, as I mentioned at the beginning, the International Resource Panel of UNEP, so the IRP, and the report that just came out is also has been funded partially from Horizon Europe. So coming back to closing the circle, read that report, please, after this meeting, if you have time. And I think this is all from my side, I believe. Okay, I think this is the last slide. This is just to also give you an update where we are. We are also having intensive conversations with the US counterparts, our US colleagues dealing with circular economy and circularity programming of research programs. And we have a consultative group together. And the US, as well as we in the EU, are very much focused on several areas that you can see listed here. So eco-design #1 is also very much in the focus of the US research authorities. Product information sharing, digital product passports, the role of consumers and local communities in the transition, and very importantly, the EPR schemes as a steering tool. So this is just something interesting at the end to show you. So I think this is all from my side. Back to you, Martin. And if you have any questions, please ask. Thank you.